All right, so the last thing that we need to be able to do with series is twofold, actually. The very last thing is tomorrow. That'll start tomorrow. The last section of the year, it's Lagrange error bound, which is kind of like the alternating series error. But example 13 is the second thing, and that is finding exact values of infinite series when it's not geometric, right? So this kind of extends the types of series that we can find, or convergent infinite series, I should say, and find the exact values of. So for sure, we know for a geometric series, if it converges, it's going to be the first term over 1 minus r. But another way to find exact value of series is if we can recognize a series as a particular series that we memorized, evaluated at a specific value of x, like example 13a. If you look at example 13a, 1 minus pi squared over 2 factorial plus x to the pi to the 4th over 4 factorial minus pi to the 6 factorial. I claim that we should be able to figure out what that sum is. And it's not geometric because it's got factorials in the bottom. But do you recognize that as almost similar to something that we have memorized? It's an alternating series, right? We memorized 2 alternating series. Sine and cosine we memorized. This one, if it's got a shot, has to be which of the 2? It's got to be cos because it's even, right? It's got even powers. So this is actually cosine, but instead of x, we see a what? Pi, right? So let's just review that. Cosine of x was 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial plus dot, dot, dot. So really, this is nothing more than cosine of not x, but cosine of pi. And what is the value of cosine of pi? No, -1. And that's the answer. This is an infinite series that converges to -1. See that? So that's not that difficult. So if you're expected to know what the sum of a series is, and it's not geometric, it's probably going to be sine, cosine, or e evaluated at some point. All right, let's look at this next one. 1 plus natural log of 4 plus natural log squared of 4 over 2 factorial, blah, blah, blah. It's not an alternating, so it can't be sine or cosine. It's got factorials, so it can't be geometric. I guess it only leaves e, right? E to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot, dot, dot. So this looks like it is in place of x. It's a what? A natural log of 4. So this is just e to the natural log of 4. And what is e to the natural log of 4? 4. There you go. That's what the sum of that series is. It's 4. Okay. That's e to the x evaluated at natural log of 4. All right, you do the last one on your own. Ready, go. Yeah, so if you notice this one, there is a common factor of 2 all the way through, and it's an x cubed, x to the 5th. So this is really 2 times sine of not x, but sine of pi 6, which of course is 2 times 1/2, which is 1. So that's the fanciest probably version of 1 you've ever seen. Yeah, basically. All right, and that's it for this section. So